Okay, it's 2 minutes past 2. So, welcome to HAO Colloquium. Today, our speaker is J. Pashakov. Um, J. Pashakov, Field Memorial Professor of Astronomy at Williams College, Williamstown, Massachusetts, is a veteran of 75 solar eclipses, including 36 totals, starting with his first as a Harvard freshman in 1959 in a seminar led by solar expert Donald Menzel. After his PhD, also at Harvard, and a postdoc there, during which he and Menzel observed the 1970 totality from Mexico. He worked with Halzerin as a postdoc at Caltech and its Big Bear Solar Observatory studying the solar chromosphere. His specialty has been high resolution solar observations, especially chromospheric specules, about which he wrote his PhD thesis. Based on observations at Sackpeak, he obtained with Robert Noyes and Jacques Beckers in 1965 before going to Williams College, where he is completing his 50th year of teaching. Pesakov has received the Education Prize of the American Astronomical Society, the Prix Jules Janssen of the Société Astronomique de France, the Richemere Memorial Lecture Award, American Association of Physics Teachers, and the Klumpke Roberts Award from the Astronomical Society of the Pacific. He is long-term chair of the International Astronomical Union's Working Group on Solar Eclipses and a former chair of the AAS's Historical Astronomy Division. His current research about eclipses is sponsored by Grant AGS 1903500 of the Solar Terrestrial Program, Atmospheric and Geospace Science Division of the NSF. Much of his earlier eclipse research was sponsored by the Committee for Research and Exploration of the National Geographic Society. Today, Dr. Pashakov will be speaking on science at solar eclipses. To Pashakov now.
Well, thank you very much. It's a great honor to be invited to speak at the High Altitude Observatory. I wish we could all be in person, and that will happen one day. I was just given an update of the eclipses that I have seen over the years. Fred Espenak just updated that with the two 2021 eclipses, and I will I will discuss a little bit of that afterward. But also I've have two recent papers in solar physics about recent eclipses that I want to discuss some of the scientific results. I was amused to see the image of the Earth from the Discover satellite with the EPIC camera, in which we see the actual moon in front of the Earth. And had we been at the sun instead of at the camera, we would see the circumstance for the total solar eclipse. And the launching of the spacecraft has led to rockets going around space and rockets going around the far side of the moon. And we're going back to the moon, and maybe we'll have people on the moon observing eclipses again. Here is a list of the eclipses of this decade from 2021 to 2030. And I'll be discussing the most recent eclipses, including the one in December that went over Antarctica that we observed from the ocean east of the southern tip of Chile. And also earlier, there was an annular eclipse in southern Canada that went over the North Pole and into Siberia. So we're discussing those, and then future eclipses in decade and otherwise. I am a little amused that in 2021 we had one eclipse that was visible, and there's one reason I'm showing images from that camera, visible over the North Pole, although we observed it from the other side, from the Canadian side. We would have gone to Greenland had we not had the travel restrictions from COVID, but in any case, the eclipse went over the North Pole. And then a few months later, we had an eclipse that went very near the South Pole. And I did observe that one, as I just said, though on the other side of the Earth from this, that we observed from a plane out of Punta Arenas in Chile. You mentioned already in the introduction my mentor, Donald Menzel, and many of you may know that Menzel was integral to the formation of the High Altitude Observatory back after World War II, when he spent so much time doodling at meetings that he developed this style of doodling. But then he worked to set up the Sacramento Peak Observatory and got Jack Evans to be director, and the High Altitude Observatory, and set that up in Climax, Colorado, which was near his boyhood home in Leadville, Colorado, which is a good reason why he put it there. In any case, his style, and this was the frontispiece of my PhD thesis that was mentioned, we can see the polar plumes, and we can see the polar plumes and the equatorial streamers, and so he did work with Walter or Roberts in the High Altitude Observatory, which obviously has now moved to Boulder. Though I certainly am interested in seeing solar eclipses and telling people and the general public about how dramatic they are and how wonderful it is to observe a total eclipse, we do have many of our science goals for my research that we carry out. And briefly here, we've observed long enough that we've been through several solar cycles. So we're watching the streamers and plumes as they change over the sunspot cycle. We're looking for coronal mass ejections, and did have some at eclipses, not to be confused, as was perhaps done 100 years ago with some eclipse comets. And we're all interested in space weather these days. And in particular, we do a lot of spectroscopy that I'll be describing. I also have this historical interest, which has led to studying the work that Jules Janssen did in discovering helium at the 1868 eclipse, with Lockyer a little behind outside of eclipse. And then there's a new book coming out from Tom Huckey of the 1869 eclipse with the discovery of the coronal green line, which took then 70 years until the 1940 work by people, especially Ed Lane and Alfvén, and identifying, say, iron-14 as 13 times ionized iron. And I'm working now with a spectroscopist, Aris Vogaris, who's taken a special interest in argon-10. And in fact, I borrowed a Leo filter from Big Bear a couple of years ago, which Aris modified to be able to image in argon-10. And then, of course, the scientific question, that's a key question in astrophysics in general, is why is the corona that hot? And I actually did a paper with Jeff Linsky some years ago in the International Ultraviolet Explorer on whether there was a lukewarm corona. And in our paper, we found really an abrupt difference between just hot gas outside the stars and an abrupt onset of a corona. One of the many ideas that are still around for how the corona got to be 1,000,000 kelvins is the surface Alfvén wave proposal of Jim Ianson, in which it's not just surface Alfvén, it's not just regular Alfvén waves with periods of a minute or so, but just in shells on the coronal loops that that could give periods of less than a second. And so we have been working for some years with high frequency observations on coronal loops at eclipses with some success to find signs of excess power greater than 1 hertz. And then I've been working on the side with Marcos Peñalosa Murillo, who spent the Fulbright year with me at Williams, a Venezuelan astronomer, unfortunately deceased as of some months ago, but he studies especially the weather circumstances on Earth and the waves, gravity waves, for example, that can radiate from the sides of the eclipse path with the abrupt change in brightness. Here is one of Aris's spectra, and we were fortunate to have 2 very recent papers in solar physics, including one of which Aris is first author, going back to the Svalbard eclipse of 2015. And this illustrates very nicely the sodium D1 and D2 lines that people knew about, even in 1868. But Janssen saw that there was a brighter line, and maybe even bright enough to see outside of eclipse. And that worked out to be otherwise unknown. And so they called it helium. There's a wonderful book by Biman Nath a few years ago, half a dozen years ago, on the story of helium and the birth of astrophysics and how fundamental this is to modern astrophysics. And then the following year, in 1869, the coronal green line appeared in an eclipse that went across the United States, including our state of Iowa. And Tom Hockey is busy writing about that now from the historical point of view. So we have in this graph both the chromospheric lines and the coronal line here. There's also a coronal red line, and that was discovered subsequently. So we recently, just in the last few weeks, had the final publication of a paper by Aris and a couple of colleagues there, and the late John Saradakis, with whom we've been working for many years, and me about the Svalbard eclipse with his slitless spectrograph. So we have a whole series of the spectrum here, especially the chromospheric spectrum, and then the emersion of the coronal spectrum, green line and red line at the maximum of the eclipse, and then third contact brought out the slitless spectra on the other side, and so this is the caption here. Flash spectra at second characteristic show hydrogen and helium, not to mention iron 14 and iron 10, and you can see this paper in solar physics. So we've done careful work with continuous subtraction here, and then taking out the K corona and enhancing the spectral lines that we see from our slitless spectrum, and the green coronal line here, and then there are all kinds of coronal lines that are now detectable on the spectrum, the iron 10, so-called coronal red line, but all these high excitation lines from the 1,000,000-degree temperature of the corona. And then, of course, there are all these single curves, largely from the solar chromosphere, though with a few atmospheric bands from the Earth's atmosphere. So subtracting some of the spectral images reveal the spectral lines in the chromosphere, in great detail, and we have tables of them. And of course, each time things are different. We compare with the results with the Solar Dynamics Observatory and the HMI for the magnetic field and sunspots, and the atmospheric imaging assembly that my colleague Leon Golub, our colleague Leon Golub, built for SDO in the extreme ultraviolet, and we see some of these results also then going down to H alpha. So we've processed very, very thoroughly the active regions and are following them. What we get at the time, and here is a comparison of our slitless spectrum of iron 14, the coronal green line, with Solar Dynamics Observatory's iron 14 observations, which of course must be comparable. And here is the coronal red line.
Jay, I'm sorry to
Yes?
interrupt you. I'm terribly sorry to interrupt you, but the slides are not advancing, so you're a couple of slides ahead of us.
Okay. Has it advanced now? Does it say raw at upper left
No,
of the
it
slide?
says, no, now I'm seeing the 3 spectral stacked images, ABC. I think we're a few slides behind you.
That is odd. Let me, I don't know why you shouldn't be seeing my screen. Is anything changing?
I'm still seeing the 3 spectral stacked. Oh, now we just see panel A of the solar corona. We've got the iron 14, iron.
On the
Let's see.
top?
Yeah, so we've got SDO and the slitless spectrograph on the left.
Okay, and what happened now? Did something just happen?
No, not yet.
I'm gonna go out of display and go back into the display. Did something just happen?
We're back to the 3 spectral stacked images, ABC. So we see the slitless, okay, now we see panels A and B, the photometric profiles.
Okay, so that one slide seems not to be displaying. I don't know why.
Thank you.
Well, so anyway, here are 3 different times after second contact, and we can see after second contact and after third contact the different size of the sun and the coronal green line at some high resolution, and here we're correlating it with the white light image. Did this now advance to bright versus dark continuum bands?
Yes.
You see that? Okay, so there was one slide that wasn't showing for reasons we don't understand. But anyway, so here is a display of the active regions and the non-active regions that we've been studying, and the spectrum here. Let's for example see the second contact and the third contact active regions on the opposite limbs, and here are the comparisons, and we've been analyzing the differences here in the spectrophotometric profiles. So here again is the D3 lines versus H beta there in the chromosphere. So here are the eastern and western limbs, and the various active regions labeled here that we've analyzed, and yet we had a quiet prominence in active region 5 with little continuum. So we do have a comparison of brightness between the eclipse that we saw in Svalbard in 2015 and the eclipse that we saw in Siberia in 2008 here, and of course that's related to the deep solar minimum that we had in in 2008, and we've calibrated and measured the power in these observations. And the brightness, as you see here, is the coronal green line is brighter in 2015, and we followed the ratio of the coronal green line to the coronal red line in calibrated studies over the years, and we can see that the ratio is greater than 1 in favor of the coronal green line at near a solar maximum, and at the solar minimum, the coronal red line at iron 10, of course, is brighter there. And here are just calibrations that Aris made of his slitless spectrograph. Let me move on to our most recent imaging paper, which appeared also last month in Solar Physics. And this was from the American Eclipse of 2017. And the paper is jointly written with my colleague Vojto Rushin from Slovakia, with whom I've been working for a number of years. And my team worked in Oregon, but we also got some observations from a team with Tom Economou and colleagues in an hour later along the path in Illinois, so we can look for changes in over time. And we're obviously very pleased to see the high resolution imaging that our computer expert Roman Vanur was able to do. And it was clear enough that in fact we could even bring out the lunar features on this dark side of the moon that's facing us. But we're clearly seeing helmet streamers, and we're seeing the polar plumes very well, and we're seeing some prominences at the base of this streamer here, and overlapping streamers.
We are not seeing your slide, I think.
You were not seeing this slide?
No, maybe next slide you are talking about. We are still seeing graphs corresponding to the photometric.
Oh dear.
Hey, your audio is ahead of the slides that we're seeing, or the slides are behind your audio.
Well, I don't know how that makes sense. Are you seeing yet my title slide for the imaging?
Right now, what we're seeing is a slide that says K continuum brightness variation.
Jay, I wonder if maybe it would help if instead of being in present mode, if you try a different mode. I don't know if that's what's delaying the slides to us.
Yes.
Maybe somebody else has another suggestion.
Well, how about this? Are you seeing? Are you
Yeah,
seeing?
I can see that. I can see that. Maybe you can try going to, like you're in slide 28. If you go to slide 29, maybe we see that. Yeah, see, we get that right away. I realize it's much smaller. Maybe somebody else here is a little more tech savvy than I am and has another idea.
Well, maybe I can enlarge it a little bit. Let me just enlarge it to this presentation mode here. Okay. So maybe this will advance better. I'm sorry about that. Are you now seeing my imaging slide with a title for the 2017 solar physics paper?
Yes.
Yes.
Okay, well, let's say in this mode, and enlarge this as much as possible. So anyway, here's the joint paper with Vojto Rushin from Slovakia with a SUVI image pasted on. I'm very pleased and proud to have Kevin Reardon and Dan Seaton as alumni of my program at Williams College some years ago when they came through, and it's been a pleasure to work with them. And in any case, here is a composite here, clearly with the polar plumes showing very, very well. And here is a composite image here, and this is what I mentioned. It was so clear that we're even seeing the features on the moon, the side of the moon facing us, which is, of course, the dark side of the moon, since the sun is illuminating the far side, and the prominences and the overlapping streamers and helmet streamers, and the plumes, about which I'll say something in another second. Here is the solar cycle, and you can see how far down on the solar cycle that eclipse was in 2017. And I dare say everybody in the room or the virtual room listening to me saw that eclipse, which is unusual for me, and I'm very pleased about that. Here is the SILSO graphics out of Belgium. And as you probably know, the yellow is the daily images, and the red and blue are averages of some kind. And you see we're in a period in almost 2017, 2018, with a lot of images with no sunspots on the sun on those days, which went to a really dead period soon thereafter. And now we'll see what happens now. We're clearly coming up, and we'll see what happens in a couple of years for the 2024 eclipse that I'll say something about later. Anyway, we've analyzed the various streamers here and followed the individual ones, and compared with what we're observing with LASCO. And the point I like to make, and I don't have to do it with this particular audience, is that LASCO leaves this donut uncovered, and only on the days of eclipses do we get a full look at the sun, from whatever we paste on to covering the solar disk to the C2, and outside of that C3, and then the question is, what active regions are there on the front or the back of the sun? Sometimes we see eruptions that in the past we have been able to follow through our eclipse observations. So here's a close-up of the base of helmet streamer A there, and here we have the solar ultraviolet imager, SUVI, that I know Dan Seaton worked with especially, and here's a helium 304 angstrom image of the solar surface, and we're following these individual features and changes of the features in the hour that it took the eclipse to go from Oregon to Chicago. So here is a view of polar plumes here with the base of a helmet streamer, and we have some big changes that we've been able to follow in that 1 hour time and measure velocities at the outside the solar limb as we see these high resolution observations. One of the things that Rusin is an expert on is what's called the Ludender flattening coefficient, in which the coronal isotopes at 2 solar radii are graphed over time. And here are the isophotes up to 3 solar radii using our images from Salem. And one can follow the ellipticity of the isophotes over time, and so we have measured that flattening out to a couple of solar radii, and then we get new contributors further out. And here is a graph going back over 100 years with the most recent solar cycle in red, and you can see, as it must, how the flattening of 0.25 applied also in 2017, and the much rounder ellipticity, most circular, applied more at the solar maximum, with coronal streamers rather at all latitudes and covering up. in fact, the polar plumes here. But we have beautiful structure that we've been able to study and follow the evolution of features there here and see how they change in the hour between Salem and Illinois. And so here is a Salem view, and you can see a brighter streamer there. You can see an absent plume. I meant to say plume, a plume here and a semi-absent plume there, and how that plume has brightened in the hour that it took to go to for the path to go to Illinois. So here's a SUVI image at 195 angstrom, tracing back things that are on the limb with the lower portion of the corona. And I've been glad also to get some information from John Burkpile about the observations from Mauna Loa of the polarization of the inner corona. So anyway, we have details in the southwest limb here, and several loop state positions and a couple of prominences, and we're following those, and as they change. Nice prominence there. Anyway, jumping ahead, in 2018 there was no total solar eclipse, and in fact, in the years with no total solar eclipse, we have what's called the Solar Eclipse Conference somewhere in the world. It was in Belgium in 2018, had been run originally by Patrick Poitevin, and it's a joint conference with amateurs and professionals. And 2022 is going to be another year with no total or annular eclipse. And the Solar Eclipse Conference is set for Sigüenza in Spain, outside Madrid, for September 1st and 2nd, and many of us are organizing for that. For 2019, long in advance, I had arranged to be on the center line in Chile, and then there was a call from the NSF and AURA to allow 5 teams of 4, to go up on Cerro Tololo. So needless to say, as a glutton for observations, I applied for that and was granted 1 team of 4. Kevin Reardon was my scientist representative at that team of 4, and Aris Folgaris brought spectrographs and cameras and his observations, and then Alan Slisky and David Slisky are more instrumentationists who observed. And you can see the double Bailey's bead effect at the between first and second contact, fading into the chromosphere over here, and then the view of totality coming out with a single Bailey's bead and diamond ring there. So we had the 2020 eclipse. I have observations of the 2020, that was 2019 eclipse, of observations of the 2020 eclipse from people who were over the border into Argentina. My team in Chile, where I was not allowed to go, didn't have good weather for that. But in 2021, we were able to travel and to observe from 21,000 feet above the clouds and weather. So here's a view out of the plane of the umbra and totality there, and of course a view at a distance far out of the eclipse here. And we did have several students with us from Williams College and elsewhere. David Slisky just getting his PhD in exoplanets, and Peter and Anna, students of mine at Williams, and Mujo, an alumnus now working at SpaceX, and we were able to get very good observations. We left Punta Arenas in a flight path arranged by Glenn Schneider of the University of Arizona, and get the sunrise point here to see the sun low in the sky, which is actually similar to what Donald Menzel arranged for our student group back in 1959 when I saw my first eclipse. And then the eclipse path went over the ice in Union Glacier, and we did have a team who were able to, run by Janet Boris and Theo Boris, able to orient themselves on Union Glacier, and then more observations from my colleague Patricia Rojo from the University of Chile in Santiago, who went with the Chilean Air Force to another team. And so there was about a 3-hour flight after midnight out to intercept the perpendicular flight path during the eclipse at just a few degrees above the horizon. It was actually, to my surprise, Santiago and Punta Arenas is actually due south of New York City. So we were traveling due south. The heading when we went home was 0 degrees. But here is Antofagasta, near where we had a Putre eclipse in 1994, even with Kevin Reardon there with us, and then down along the coast of Chile to Punta Arenas there. And of course, there are many advantages to being at high altitude, including being above the clouds, and we wound up having 2 planes, so we were a couple of thousand feet higher than even planned, with a very dark sky for comparison there, and excellent seeing, and a longer duration from the high altitude for a bit there. And here is that most recent sunspot cycle or sunspot set of measurements as we are improving here. And David Hathaway, retired from Huntsville, is still working on the solar cycle and making predictions. And though there are various predictions for various heights, as many of you know, for whether the next cycle will be higher or the same or lower than the previous cycle, you can see the previous cycle was much lower than the preceding cycle. So we're watching that, and I'm working with people from predictive science for their predictions based on the magnetic field measured on the sun. Here are my Williams College students, Anna Tosellini and Peter Knowlton and Mujo Liu, as we flew out on LATAM, the Chilean airline, to Punta Arenas to make those observations. And then the pilots, we usually get the most qualified pilots of the different airlines who have the difficult task of being in the right place at the right time most precisely, even if it requires a little looping to delay. And here I am with the captain who did so well, and Tim Todd, who arranged this all, and one of the many cameras we had photographing out the window soon after dawn. We were able to have some graduate students and young teachers with us also, the National Outreach Coordinator, the IO in Chile, Maria Fernanda Duran, and these are picture that her group took with a diamond ring, and this image that you've seen already. So within a couple of days, we were able to take our images from the ice and from the plane, working especially with a colleague in New York to put together some composites and put out a press release from NASA NASA Goddard. Lena Tran there put it out, working with the people from Predictive Science Incorporated, who used the HMI observations from the Solar Dynamics Observatory to use their equations to predict the shape of the corona, and then we compare it with our own observations. And this is the press release with a slider that can go in either direction here, just a little enlarged there to show the overlap of their predictions and our observations, and of course, improve their predictions for the future. Half the time, their observations are a couple of weeks old because they came from the backside of the sun, but they do put out these predictions a few days in advance of totality, so we know what to look for. The and so here is one of the modes, and there are modes with different amounts of wavelet analysis and different amounts of logarithmic analysis to display their predictions based on the magnetic field. So here's what they put out: early phase of the new solar cycle, so that it's evolving rapidly, and the coronal appearance changes in several days. So they worked to do the digital processing of the brightness, and the wavelet analysis we see here to see the details that they can bring out, and in fact extending the solar magnetic field much further into space.
Jay, I think we're still seeing slide 66 that says coronal prediction for December 4th.
Okay, let's have you.
Thank you. There's slide 67. Thank you.
Okay, so this is their prediction, and with the different amount of logarithmic analysis, you're seeing a bluish one now.
Yes.
And so we can skip over that one, but they did wavelet analysis, and they're seeing the details of the parts of the streamers and the occasional polar plumes. And now you're seeing the magnetic field lines extending way out. And so this is their final prediction from a few days before totality. And then now, are you seeing slide 72? This is a composite from my team.
Now
It just came up.
Did
Did it catch up?
Yes, 72.
All right. So these are actually our observations, and you can see the polar plumes and some streamers, and so we're comparing those with the predictive science, and we'll be reporting on that in a couple of different papers well, first of all, in the AAS meeting in June in Pasadena, and then at TESS in Seattle, near Seattle, in August. So here again is the slider between their observations and our observations from the Goddard press release a couple of days after totality, and we've worked with them before. The call for planes was enough that the travel agent was able to arrange a second plane, and so we could actually see, including some internal reflections, the second plane. But we had a near calamity a couple of weeks before totality, when the Falkland Islands refused an emergency landing spot for our plane because they couldn't handle all the quarantines, and the flight was in danger of being canceled. But LATAM was able to offer and charge for a bigger plane, a 787, that has powerful enough engines that it can stay aloft for the required safety couple of extra hours. So we did make that substitution, which we're still trying to pay for. But in any case, we were on two 787 Dreamliners for these observations, with our higher plane at 41,000 feet, so-called plane gold, and the lower plane blue at 39,000 feet. And ARIS had quite a setup of a couple of spectrographs and imaging here, and observed these active regions in here and observed in these displays that Ara set up with Tom Economou from the University of Chicago. We're seeing at the left side and the right side, so the spectral lines are doubled here, and here's the spectrum of iron 14 and iron 10, and the active regions here that we're studying here. Now, from the ground on the ice, Andreas Müller from Germany had some excellent observations, as did Theo Boris and others, and you could see the diamond ring emerging on his observations there at the end of totality, and Bailey's bead spreading there. And in this very nice series. And then we have our composite observation here that Dan Seaton put together for me with the SUVI observation, a little bit of coronal hole and streamers coming out and merging with the C2 coronagraph observations, and a big messy streamer eruption here in this part of the field of view. And some of you are familiar with Miloslav Druckmüller's analysis with his computer methods and bringing out great detail in the shape of the eruptions that are going on, and the more stable streamers on the other side, and the coronal plumes at the poles, which in a couple of years will be covered. So here is just a label for that, with the SUVI imaging there and the 195 angstrom display that from iron 12 that was set up that Dan Seaton assembled. And so we thank the European Space Agency for SOHO, which is now, as you all know, up for 25 years, even with, but it's the U.S. Naval Research Laboratory, rather, that has made the three coronagraphs. At one point, my team made a C1 matching telescope to measure the scattered light during an eclipse and compare it with their C1, which had considerable scattered light. But then, as many of you know, SOHO spun out of control and the C1 was lost. So now it has C2 and C3 working, and here's C2. Anyway, so Theo Boris, with my alumnus from Williams, Christian Lockwood, and others were observing for that, and here's the composite here. So we have numerous observations we're really starting to study. You saw the recent paper on the 2015 spectra, and we're moving into the 2017 spectra. And then between, you saw the 2017 observations of loops and streamers that will expand to the 2019 and eventually 2021. Along on our plane was Peter Horolak further back, and you can see here the full umbra there of the 787. The higher 787 has the path proceeded from the sunrise point over Antarctica. So here's a look down at the lower plane there, and a look in the cockpit with relief after we observed the eclipse, and here a couple of observations during totality. From the lower plane, you can look up and see our plane making the observations there. Now, our group headed by Theo Boris, Janet Boris, were on the ice here, and brightening that image shows the team here, Theo Boris and Christian Lockwood, David Zimmerman, especially on Union Glacier, and using some of our images that we're working on now to put together to get the best possible composites. And we do have measuring devices for, well, the solar brightness, which obviously must fall off geometrically, but then differences in the temperature and pressure, which was more straightforward fall at Svalbard than the variations that were recorded in Antarctica. But anyway, these are our observations here now from the ice, and that did appear in the astronomy picture of the day, just a few days after the eclipse. And there were some other astronomy pictures of the day as well. There might be hour by hour, but without totality. And from the actual South Pole, again, someone, Aman Shuksi, you can see total. You can see the umbra, but you can also see that the eclipse was not total from the actual South Pole. Now, Patricio Rojo, the astronomer from the University of Chile, had 3 camera setups with him, and including a big telephoto that I supplied. And we have 33 fine frames that have been composited here, and that we'll be working further with as we get the time to do that. And here is a view of that view with polar plumes and equatorial streamers and some streamers here. So we're certainly pleased with what we were able to get on December 4th. If you were looking at the weather satellite down, you could actually see the path of totality. So we're not in the video now. Let's see if this is that. Are you up to that slide, to the Antarctic view? Can you see the shadow go across?
We're seeing slide 104.
Well, you're not seeing the shadow go across, I guess. Yeah, so in 105 and 106, let me try again. 105, you can actually see the shadow move across Antarctica. You're seeing 105?
Yeah, we're seeing that movie. Thank you.
You're seeing that shadow move across, which is certainly dramatic. And then are you seeing the Discover view with a shadow on the South Pole?
Yes.
Here. So here we get that view, and I'll skip this movie of the path. But if you're on the space station, like this astronaut, Ayla Barron, she could look down and just see the eclipse shadow move across the Earth, which is something I'd dearly like to see one day, but probably not very likely. Anyway, we were pleased with what we saw on December 4th. My sister had long ago made a papier-mâché penguin, and we were able to go out and see some penguins near Punta Arenas as they waddled across. I don't know if you saw that or not, but in any case, we arranged to report on this in January at the AAS, which meeting was canceled. So we are going to give an updated version of that in June in Pasadena at the AAS main meeting, and report also on the AAS Eclipse Task Force that I had the honor to be on. and to acknowledge the NSF for their support. And then I'll give a report at the Pasadena meeting in June, in the middle of June. And then Dan Seaton and Kevin Reardon have arranged a session at TESS, Triennial Earth Sun Summit, in August 2022. And we have Shadia Habab will give an invited talk, and Sebastian, forget his last name, will give an invited talk. And then there are 5 other oral talks. Benjamin Bowe and me and Sarah Kovac report on the condense spanning Citizen Kate experiment again. And Liang Kwang will deliver an ionospheric paper, and Jenna Samra about the plans from the air. Most recently, there was an eclipse just a few weeks ago that was visible as a partial eclipse only on Earth. And I did go down to Santiago for it from Viña del Mar, and we were able to see the phenomenon together with Patricia Rojo. And it was a 40% magnitude eclipse on that day. And you can see a GIF of the sun setting in the Pacific, with mirage causing deviations from roundness of the sun. And in fact, little bits of green along the limb are a kind of green rim, green flash phenomenon that I'm very glad to follow. Are you, where are you now in terms of slides?
We still have the test slide.
You're still at the test slide.
Yeah.
Let me go back a little bit. So I got rid of. So if you're still at the test, sorry. So I don't know what's happening with the delay, but anyway, here's the test slide. And so here's the recent partial solar eclipse of April 30th, actually. And I was here at the edge of the Pacific, the edge of the continent, and we did see a partial eclipse up to 40% magnitude, and we did see the sun setting into the Pacific. And are you up to 122 now, which is just a sunset image, sunsetting the Pacific, and a little bit of green rim, green flash at the top of the setting eclipse. Goes east, was not in a place to see that eclipse when we saw it, but it did see, and I'm not sure we're going to get this. Did you see that go by?
Yes, you can see the moon go by.
You see the moon go. So that's a couple of hours earlier there for that most recent eclipse. And then the next partial eclipse will be in October, and I'm not going to go to Kazakhstan for obvious reasons, but I will go up high in Scandinavia to see that eclipse on October 25th. And maybe we're running out of time, so I will skip over a few of the solar orbiter pictures that have recently been posted, but the very exciting images the solar orbiter is taking from much closer to the sun than we are. And when it crossed the Earth-Sun line on March 7th, it got a good series. And then just today, the European Space Agency posted a perihelion picture, I believe, from when they were very close on March 26th. So this is arguably the highest resolution image ever gotten of the sun there in the extreme ultraviolet. So anyway, back to TESS. Shadia Abal, Sebastian Merak will give 2 invited talks in our session. And then Benjamin Bowie and I and Sarah Kovac report on Citizen Kane. And Shibachi Chakraborty will work with Liang Yang, who will deliver the paper about the ionosphere. And Jenna Sammer will talk about airborne plans for the NSF plane. And then there will be several posters from Amir Caspi, the WB-57, and Sherilyn Morrow. Cooper Downs will talk again about that modeling with the that I showed you some images of. Alberta Ding on high resolution spectral observations, and Andrew Roberts on more high altitude and late edition, Noor Rafi. And now, in closing, just give me a couple of more minutes. The next total solar eclipse is it's called the hybrid because it's annular at the very beginning, but it's perfectly good total eclipse over most of the path. And in East Timor, it's usually cloudy, but just tipping the upper left-hand corner of Australia in Exmouth, we're hoping to see it there. So many people are going there, many more than the capacity of the land and the travel. There is a gong site there, but so solar physics does have representation there, but we hope to see that eclipse in less than a year from Exmouth, Western Australia. And then there's a path that's not unlike what we saw in 1970 when Donald Menzel drew this for our National Geographic article that hit the Pacific coast of Mexico and came up through the continental United States. And in 2023, we'll have first an annular eclipse that will come across on October 14th. And the clearest forecast is for Albuquerque, New Mexico and Utah. And it goes in through Texas, crossing the path on April 8th, 2024, which now is less than 2 years away. But as you know, New England is not a very good weather place in April with kind of 60, 70% chance of clouds and maybe 50% chance of clouds, 40 or 50 in Texas. And Jay Anderson, with whom I just did a field guide to weather, has compiled 20 years or so of weather statistics, and it's the best chances are here in Mexico, and we intend to have my team on the in Mazatlan or nearby on the Pacific coast of Mexico for that total eclipse of April 8th, 2024. So maybe I'll see most of you who are listening to this talk today there. Here is Jay Anderson's site, and the blue is good. And so that's why we want to go here and not Biddling in Texas and not arguably bad in New England, and then Buffalo and Niagara Falls are in the path in 2024. There are a couple of books that we should all read. David Barron wrote a wonderful book about 1878 eclipse, and Tom Hockey has been just did an 1869 total eclipse book for which I just wrote the foreword, and that's very interesting for the survey. In my book with the art historian Roberta Olson, we have a chapter in a book on the art and science of the universe on eclipse imaging, and way back in 1918, 23, and 25, we had an oil painter who made sketches during totality and then was able to make a beautiful artwork. And that was the best way of recording what the corona was like at that time, because the photography was so slow, the ISO was so slow. And then Leon Golub and I did a book about the sun for the Science Museum of London a couple of years ago. And then in real closing, the following eclipse will come across in 2045, which is only 25 less than 23 years in the future now. So certainly the younger people in the audience will hope to see that one. And there are two new eclipse globes, one of the 50 years from 2021 to 2070. It came out of Astronomy Magazine in my science shop, and then out of Sky and Telescope, a bigger globe with all the eclipses in the 100 years of the 22nd century, and you can see the path coming across here through Colorado in 2045, and including where you maybe your homes are in Colorado in 2045. And I'm holding out less hope for the eclipse of 2079 or of actually seeing it, but it does start over New York and Boston, and in fact in Williamstown, Mass, where I am now. So some people, and some people who were born today in 57 years, will be able to see the beginning of that eclipse of May 1st, 2079, with its elongated shadow, and that will be exciting to see from where I'm speaking now, which is right on this edge in Williamstown, Massachusetts. And so I doubt that I'll be around in 57 more years to see this, but I hope some of you are, and I hope you all get to see the next few eclipses. And I thank you very much for inviting me to tell about some of our eclipse observations. Here, I'll just put a picture up on the screen of a good composite, and it's been a pleasure to talk to you and to be involved with the High Altitude Observatory, whose work and Gordon Newkirk's long series I certainly have been involved with and respected over many years. So thank you for inviting me.
Thank you very much for very comprehensive talk on solar eclipse, and we really enjoyed. Other than this time delay in the slides, it was fine. And I think Roberto has a question. Roberto, you raised hand.
Okay.
Roberto, are you there?
No, sorry, it was a mouse misfire.
Oh, okay. Okay, so anyone, now the room is open for question. You can just unmute yourself and ask your question, or raise your hand, or put in the chat.
Masumi, should I stop presenting, or are you seeing?
You can stop presenting. Here.
Okay, so we can see various people, including even centrally Jeff Linsky, who I'm always glad to welcome. He and I were in graduate school together, starting, I think, in 1963 at Harvard, unless he came a year later. So hi, Jeff.
Mute. Hi there.
So yeah, this is Philip Judge. Thanks so much, Jay. It's a privilege and for us to have you speak to us here. I think it's probably been far too long since you last did, and I had the pleasure of reviewing the latest solar paper on the imaging spectroscopy for solar physics, and I got to
for which we got extremely knowledgeable comments that we dealt with, well, and eventually convinced you to let it be published in Solar Physics. So
well, you did a really great job, and you were very kind to the referee, and overly kind, and I suspect that's been your method throughout your career, but I don't know that particularly. Anyway, I did want to to bring up the fact that I'm just as a statement, I'm wondering when we go to the mid IR, how dark a sky we're going to actually be able to get to there with things like DKIST, and whether we're actually going to get down to the kind of levels that you regularly have achieved over the years and many others have during the eclipse. So what's nice there, of course, is in the mid-IR, you have a very strong sensitivity to Zeeman effect, simply because the Zeeman splitting is so big. And so anyway, I don't know if you're particularly interested in the first results from DKIST. I suspect that we all are.
I certainly am.
Yeah. So do you suspect we will perhaps see some resolution, some refutation of coronal heating models in the next few years? You mentioned the work trying to test out the work of Jim Ironson.
Yes. So I'm aware of the recent papers, some recent papers on coronal heating that go up to 17 different models of coronal heating. So I like to say that the problem has been solved, but it's been solved in 17 different ways, which of course is saying that it's not solved. And of course, we'd like to resolve one method as above all others, but it's certainly possible that there can be several different contributors. So I have read about the sky background for DKIST, and so I'm assuming that there'll be great observations in as you point out with the Zeeman effect, and I'm looking forward to it. I'm hoping also to be included in some observations. I had corresponded with Valentin about it on the chromosphere, and I know that most people associate me with the corona, but maybe my main solar work, my main scientific work over the years has been on the solar chromosphere and spicules that I've continued at the Swedish Solar Telescope more recently, much more recently than my long ago SAC peak work. But I hope that I can be participating in some DKIST chromospheric work also. But and then I didn't mention the European attempt at putting in a couple of years, and Dan Seaton is involved with it, I know, of putting up a couple of orbiting spacecraft in which for a couple of hours out of every 6, somehow, one spacecraft will be kilometers away, I think, and therefore in decent focus to make a much better occulter than we're able to do with the small stuff like SOHO, and just how good our observations will be starting in a couple of years of the corona from that will remain to be seen. So I'm certainly glad to see everything going on, and Parker Solar Probe and Solar Orbiter. So and with DKIST coming online, it's just wonderful. I would have been out last year with a group of students from Williams College to DKIST if it hadn't been for COVID, and I hope that may happen yet. And that would have brought us to Boulder for a couple of weeks also. So I hope you'll see me again and see me with my students, and we'll be able to advance solar science. And I thank you again for your yeoman referee's work. And it may be that you've just gotten yourself into receiving an earlier draft from me the next time.
Okay. There's one other thing I wanted to ask you as well, and that is, have you followed much the stellar eclipse work, where they're trying to find very dim things next to stars, and do you have any thoughts on that?
No, I haven't. I certainly follow in general, and I teach a general course, wrote a general textbook following the exoplanet work. but I am interested in seeing these things. But I do like to make the point that I'm interested in the astrophysics of the things, and I'm not busy searching for life on other planets, which I think is a low probability thing. I was just describing to somebody today that I was glad to devote my career to something in which there are exciting results all the time, namely the sun, and not looking for something with a low chance of return, such as discovering life on another planet.
Thank you.
Any other questions for Jay? You can speak up or you can raise your hand.
Well, I will hope to see many of you at Pasadena, and especially at TESS.
Okay, bye.
So please, let's try to get together if we can.
Okay, so if there is no more question, let's thank our speaker again.